Hi kids, sorry for another video lesson, but actually with only 38 minutes of class today, I think this is actually a good thing. So because this lesson has lots of algebra, it's going to take a little bit of time. First I wanted to show you this cute little demo of two inverted cones and the cross sections as you pass a plane through them. You see the hyperbolas, and now the hyperbola disappearing as you exit one of the cones. Parabola, open, open, open until up, closed. Now there was an ellipse, then a circle. Now the circle with a radius shrinking, 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 shrinking. Degenerate. Now a line and intersecting lines, degenerate conic sections. Right now back to the hyperbola. Right? Hyperbola, hyperbola, and tilting away until I get parabola. Now an ellipse until I'm parallel to the base. Then I have a circle. Right? Kind of cool. All right, if you want to go ahead and get out your warm-up books. If you haven't already, copy this warm-up down. I'll give you a few minutes. Your homework is in the book, right? I don't see you tomorrow, so this won't be checked until Wednesday is the next time I see you, I think. 3 through 13 odd. You don't have to do number 5. I can't remember if number 5 is just a problem I don't like or if it's one of the examples I used in class. I don't remember. We will have our test on Thursday, not this Thursday, next Thursday. Test on Unit 9, Thursday, May 31st. No calculator on the whole thing. So please make sure at home that you are practicing the algebra with there's some larger numbers, right? In order to make all these perfect squares happen, we've got to have some larger numbers, and you've got to divide, right, and be able to factor, and you've got to be able to multiply, add and subtract, all without a calculator. All right, if somebody's asking me to write the equation in both of these, speaking of a test, both of these are great test questions because they test vocabulary and concepts without making you graph or do any algebra. So they're quick problems, or expected to be quick problems. So for both of these, you're expected to know the graphing form. Don't expand to general form unless somebody makes you. Of a hyperbola and an ellipse. For an ellipse, I'm not worried about signs. Everybody's positive, right? But underneath each group, I have to have Rx and Ry squared. So for the first one's a hyperbola. Now, as I told you, nobody asked you to graph, but I'm going to go ahead and at least mentally think about 0, 0 as my center, and then my focal points being at 5 and -5. What does that tell you? Focal points are captured inside the hyperbola, right? Inside that soup spoon. So that means if this distance, C, is 5, both A and B have to be smaller than 5. Also, since the center and the focal point are vertical, it tells me that the Y group must be positive and the X group needs to be negative. The next thing I go and look at, notice I didn't look at this in the order from 1, 2, and 3. You're expected to know that the slopes on a hyperbola, the slant asymptotes, have slopes that are Ry, because slope always has Y on top, over Rx, but you're also expected to be aware that this ratio, which right now is 4/3, could have been reduced. But with focal points that are the focal length, which is again C, and in a hyperbola, C is the big boy on the block. If both Ry and Rx are smaller than 5, I know this fraction wasn't reduced from anything. So I can go ahead and put not 4 but 16 under the Y, and 9 which is 3 squared under the x stuff, and put the center in here. So of course I don't have to put 0, 0. Could have just had negative x squared over 9 plus y squared over 16 is equal to 1. Remember, Rx are the vertices that got cut, right? The vertices that got cut. And your asymptotes go through the center. I didn't ask you to write the equations, whoops, of the asymptotes, but if I did, you would use, right, the equations of the asymptotes in this case would just be, because the center is at 0, 0, the equations of the asymptotes would be technically y minus 0 is equal to plus and minus 4/3, x minus 0, which of course simplifies. Just be careful. I have a lot of kids writing equations of asymptotes assuming that the center is at 0, 0, and it is rarely at 0, 0, right? Now let's go back to the ellipse. The center is 3, 4. And you see the trap in this one? I've used the center. The trap in this one is to use 14 and 10 as either Rx or Ry. Firstly, I don't even know which one is Rx and Ry yet, right? Because no one has told me whether my major axis is vertical or horizontal. But with a center at 3, 4 and a vertex, not a co-vertex, at 10, 4, I know this length from the center out to a vertex must be A, and how long is that? Starting at 3 and ending at 10, A is 7. Well, that's a dagger. Neither major axis or minor axis is 7. Oh, right. The major axis is 2 times A, and 2 times 7 is 14. So since A is horizontal, I'm going to put my major axis information under here, but I don't put 14, right? And I don't put 7. I put Rx squared. Therefore, I have the minor axis, which is to be or not to be. Wah, wah. So B would be how long? Yes, 5, but you don't put 5 under here, you put 5 squared. All right, keep that, keep the warm-up book out and add this next one. This is a challenge. It looks like it's the same because I'm still dealing with an ellipse. So I say, oh, that's no big deal. Look, they gave me the x coordinate of the center, and they gave me the y coordinate of the center. My center is at negative 8, 8, and a vertex, not a co-vertex, is at 2, 8. Therefore, what is this distance? Since it's out to a vertex in an ellipse, that's A. And if I started at negative 8 and I ended at 2, how many steps is that? So A equals 10. Therefore, I'm going to put 10 squared here, and I'm just looking for B squared, right? So I look back at my information. I've used my center. I've used the vertex. What else do I have? Oh, eccentricity. Oh, that's right. I remember from my notes that eccentricity is a ratio of C to A. Well, that's cool. I can use C and A to find B. Oh, wait just a second here. They're claiming that C is square root of 21, which is smaller than 5, and A is 5. What's the problem here, though? The problem is A is not 5. I already know A is 10. How can A be 5? Fractions, my friends. Fractions. If I have a ratio and the denominator is 5, but I really want the denominator to be 10, what must be true? 5 was multiplied by 2, but that's not legal in this ratio until you do what? So the real C is 2 root 21. Now how does that help? What am I after? I'm after B squared. Remember, in an ellipse, C squared is equal to the big boy A squared, minus b squared. Let's do some algebra and get b squared by itself. Move b squared to the left side of the equation and c squared to the right. So b squared becomes positive and c squared becomes negative. And what can we fill in here? We already know a squared is 100. We know the real c, which is not root 21, it's 2 times root 21, needs to be squared. So b squared is equal to 100 minus, what is 2 squared? And what is root 21 squared? Do the order of operations, in other words, multiply this and get 100 minus 84. So b squared is equal to 16. Now, that's a little bit tricky, right? Watch out for that. All right, go ahead and get out your notes. Now you're going to use the handout that Mr. Davis has for you, but let's write in your notes the process for solving for today's objective. Today's objective is something called locus of points. What is a locus of points? Locus of points is kind of a picture. It's a graph, really, but it's a graph generated, a graph that of course has an equation that is generated by following a set of directions. Think of that as a recipe. So here's what we're going to do. First, you're going to be given all of the problems in the homework start in English. You're going to translate English to math. Then from the math, you're going to make a sketch. The sketch is not going to be worth any points on the test, but it's going to help you, I promise. Then you're going to use the distance formula, which just comes from Pythagoras. Doesn't Pythagoras look swell there? Right? You're used to the distance formula being, oh, I only use the distance formula when I'm talking about the distance between 2 points. But remember, here's point A, and here's point B. The distance between these 2 points is the same as the hypotenuse of a right triangle, where you say, how far did you go in the x direction? Change in x. How far did you go in the y direction? That's the change in y. And to find the diagonal distance, you square the horizontal distance and the vertical distance, add them together, and you will get the square of the hypotenuse, or the distance squared. I don't want the distance squared, I actually want the distance, so I have to take the plus and minus square root. We don't, since we're dealing with distance, we just ignore the negative part because that's always, so, you know, distance is always positive. This is your old x2 minus x1, y2 minus y1. How far in the x direction did you go? That's what delta says. How far in the y direction? Delta means change. Change in y, change in x. You're going to be using the distance formula a lot. You're going to simplify the distance formula. And when you simplify it, you get rid of all parentheses and square roots, and all of a sudden you recognize, I hope, the general form of a conic. The general form of a conic has no parentheses and is equal to 0. So you want to get yourself to general form. Then you're going to look at the coefficients of the squared terms. You're going to name that conic in math, right? Recognize the math from the general form, and then because you started the problem in English, guess what you're going to do? End the problem in English. So you want these notes, right, with you while you're doing those homework problems. I'm going to take you through 4 examples. How many conics have I taught you about? 4. So guess what? Each one of the examples that we're going to do is 1 conic. I'm going to tell you that it's going to be your algebra that messes you up if you're not careful. Follow these directions. All right, so on your handout, here is example 1. So first, let's identify the information that we need. For each point, that point's distance, its distance, Pythagoras. from a fixed point, x, y, is twice its distance. Let's call this Pythagoras 2, since Pythagoras 1 was over here. From another fixed point, let's call this x sub 2 now. So I better call this x sub 1 and y sub 1. I need it, when I'm done, I need an equation, and then I'm going to name that conic. So now remember this point here, this point also is an xy, but it's a generic xy. Whoops, sorry, gosh darn it. Every time I do that, the pen erases. This point is a generic xy. Now remember, distance is Pythagoras. Let's call that d1. I said Pythagoras before. From a fixed point is twice its Pythagoras distance from another point. So the first thing I'm going to do is draw myself a little sketch. Negative 3, 0. And 3, 0. So every generic point in this plane has to be, its distance from negative 3, 0 is twice its distance from the point 3, 0. So let's write distance 1 is twice distance 2. Now take distance 1 and turn it into Pythagoras. Pythagoras is the square root of x stuff squared plus y stuff squared. And then I have equals to a second Pythagoras, x stuff squared plus y stuff squared. So here's the first point that they talk about. So my random x point, right? So let's say I have a point P here. Its distance. So how do you write the distance from negative 3, 0? X minus negative 3, y minus 0. Of course, you don't have to put 0. Is twice its distance, it being xy, from this other point. How do you write the distance from P to another point? How do you write that distance to the point 3, 0? You take x and subtract the second x, 3, y, and subtract the second y, 0. Now it's just time to do math, right? So I taught you how to solve radical equations, didn't I? Remember that? Right? There is a plan. I taught you this in what unit? Right? Rational function unit. We solved rational equations. Squared. I guess these aren't really rational, huh? There's radicals. So squares and square roots undo one another. Squares and square roots undo one another. Don't forget the 2 is also squared. So I just have x plus 3 squared plus y squared is 4 times the quantity x minus 3 squared plus y squared. Right? Come on, algebra's got to go. Let's go. X squared plus 6x plus 9 plus y squared is equal to 4 times the quantity x squared minus 6x plus 9 plus y squared. So now my job, I've gotten rid of all the parentheses, now my job is to get 0 on one side. And I think I'm going to choose the left side to make 0 because I see that I have 1x squared over here and only 4 on the other side. So I'm going to take this x squared over to the right side and have 3x squareds. Then I'm going to take this 6x and subtract 6x from this 24x, so I'll get negative 30x. Then I'm going to take this y squared and subtract it from this side, so I will have I don't have any single y terms because the y coordinates were both 0, but now I'm going to subtract 9 from both sides. And now down here for the equation, I'll put everything in order. Capital A x squared plus capital C y squared plus dx, d is negative 30, f is 0, e is 0, and f is 27. So there is my equation of my conic section in general form. I identify the coefficients of the squared terms, and I say A is equal to C. Neither one of them are equal to 0, therefore my conic section is what? A circle. So this kind of problem is going to be worth 4 to 5 points. If you think you can recognize from the words what conic section you have, awesome. Write it down. But that's only going to be 1 point. Now the 1 point also might be wrapped up in the fact I'm not going to promise that this could be 2 points, but with the high volume of points that this problem could have, I might for 1 point be both the justify and the identification might only be worth 1 point. There's going to be 1 point for the equation in general form. That's in your notes, right? There's certainly going to be 1 or 2 points for all this algebra, right? And 1 point for the setup. So this problem could be worth 2, 3, 4, 5 points. Okay? Let's try the next one. What's different, what causes kids problems about the next one is this scenario. For each point, this is going to be a random point xy, those are your, right, xy, that point's distance from a fixed point is 2/3 times its distance from a line where an x is always -5. This causes kids problems. So here's what I suggest you do. Draw yourself a little sketch. Plot the point -4, -1. Draw the line x equals -5. Now draw a random point. So here's some random point. The distance, so you can do this, right? This is regular Pythagoras. A distance from its fixed point. So let's write our equation. The first distance is, right? The is 2/3 times the second distance. So that's Pythagoras is 2/3 the second Pythagoras. So this distance is fine, right? This distance is x minus -4 and y minus -1. This is the one that causes kids problems. They don't have a problem with the x, right? They're like, well, the distance, the only other x I'm given is -5. It's the y part that causes kids problems, and a lot of them do this. They just put the y in there. Watch out. Think about distance. Just basic definition of distance is shortest distance, right? What is the shortest distance from this random point to that vertical line, right? That's the distance, the shortest distance. Well, think about this point over here on the vertical line. What is the x-coordinate? What is the y-coordinate? When x is -5, didn't you just go horizontally, right? Well, let's pretend this y was 10. If this y was 10, what is this y? The same. The same y. That's the trick. Whatever the y is on your random point, when you go the shortest distance to a line, your y-coordinate stays the same. Be careful with that. So now let's just do our algebra. You ready? I'm going to square this side, and I'm going to square this side. Squares undo, that whole thing is in a square root, so I just have x plus 4 squared and y plus 1 squared is equal to not 2/3, 4/9, right? Because this is just a product. So 4/3 gets squared and the square root gets squared. So I have times the quantity x plus 5 squared plus 0. Y minus y is 0. Your algebra has to be quick, your basic algebra. Now I'm going to show you, remind you of an algebra trick. I really don't want to distribute 4/9 to all of this. Think about your general equation. Your general equation doesn't have any fractions in it. Let algebra be your friend. Multiply everybody by 9. 9x squared plus 72x plus 16 times 9, 154. No, 153, right? 9 times 6. No, 154, right? 16 times 9. Doubting myself here. 9 times 6, 54. 9 times 16, 9, 10, 11, 12, 13, 14 is 144, right? Am I doing that right? I just have in my, see, look, for me, even, basic, right? Oh, I have it in my notes as a different number because I already combined it. Ah, that's what was throwing me, okay. So 144 plus 9y squared plus 18y plus 9. I'd already combined the 144 and the 9. That's why I was looking at my notes and going, wait, where did I get that number from? Is equal to, now think about this, 9 times 4/9 is 4. and then distribute the 4 through. Now we're just combining, right? We're just combining. So I think I have a 9x squared over here and a 4x squared over here, so I think I'm going to go ahead and get 0 on the right side. And I'll take that 4x squared and add it to 9x squared. I'm sorry, subtract it. So I get 5x squared. Then I'm going to do my y squareds, and I don't have any y squareds over here. So I'm just going to have plus 9y squared. Then I'm going to get my x's together. I'm going to subtract this 40x from both sides. Then I have a linear y, but only on one side, right? 18y. Now 144 and 9 is that 153 that I started to write. I have one positive 153 on this side, but I have a positive 100 on this side, so what is that going to mean? Plus 53, right? So 5x squared plus 9y squared plus 32x plus 18y plus 53 is my conic section in general form, and the coefficient of capital A and capital C are not equal. Neither one of them equals 0, but they have the same sign. Therefore, following these directions, if I were to actually get out my protractor, right, and my ruler and follow these directions, I would find all the locus of points. That means all the points that satisfy this direction. Think of a locus as a set. The set of all points. So there's a set of infinite points that if you graphed them all following those directions, you would get an ellipse. Okay, so we've done circle and ellipse. I wonder what's next. So again, you might be able to guess from here what's happening, but that doesn't mean you're still, remember, this is going to be worth like 5 points, right? Now I can only put 1, maybe 2 of these on a test where I'm doing a whole bunch of other stuff, so I certainly can't put 4 of them. So each point is equidistant from a point as it is a vertical line. So once again, I'm going to draw myself a little sketch. And again, you don't have to, but here's the point 25. And here's the line x equals -3. And here's some random point. Well, the distance here, random point, line x equals 3, 0.25. This distance, right, the distance from point P to the 0.25, that's distance 1, is the same as that point's distance to the line, right? Well, the first distance is not a big deal. Right? Random point x minus x point I know, x coordinate I know, random coordinate y minus y coordinate I know. That distance is the same as another distance. I have to have Pythagoras, and this is the one that confuses kids, right? But if you just draw this line, if this is at 2, 5, and you're going straight across to the line where x is always -3, right? Y must be 5, right? We'll just do the same from the random point. This is the random point xy. If you're going across to the line here, x is -3 and y is whatever y coordinate, this one, the same y. That's the important thing. So the distance, unknown x minus -3, and then this y coordinate minus the same y. What is the change in y if you go horizontal? Y coordinate minus the same y coordinate is 0. So let's do our algebra, where we're going to square both sides. Remember, as long as this whole side is under a square root, squares and square roots are inverse operations of each other. Right? Square roots and squares undo one another, and this is 0. So now I'm just doing algebra. X squared I have to get an equation equal to 0. So I'll make this side equal to 0, which means I take x squared and I subtract it from this x squared. There's no x squareds left. I have a y squared over here, no y squareds. I have a positive 6x that I'm going to subtract from both sides, so I'm going to get, right, positive 6. Oh, whoops, I forgot. I've got negative 4x and negative 10x, which gives me negative 14x. And negative 14x negative 14x minus 6 is negative 20x. And then I just have to get, where's my numbers? Oh, here's my numbers. 4, 25 and 4 is 29. Subtract 9. And what do I get? If I subtract 9, I lost my pen there, my tablet. 29 minus 9, so I get 20. Did I get everybody? Got that, got that. Right, so I have a y squared. Do I have a single y? I don't have. Oh, this is a, I knew something was wrong, right? I'm sure you saw it before me. This is a y. Sorry about that, kids. I knew something was awry. I was getting a text and I wasn't paying attention. All right, let me start that again. So I've got, my x squareds do go away, right? But I have a negative 4x and a negative, so I have y squared. Let me just start down here. I'll have a y squared I am going to subtract a negative 6x, but from a negative 4x, so that's negative 10x. And then I have a negative 10y that I don't have any singular y's on the other side to combine with. And then I do have that plus 20. So it was just that I was messing that up. So again, be careful, right? I was a little sloppy with my writing, and I looked at that y and thought it was an x. So important thing here, though, is what are we doing? I'm looking for the coefficients of the squared terms. Doesn't really matter what this coefficient is, right? If a is equal to 0 and c is equal to 1, that means I only have one squared term, therefore what is my conic section? A parabola. All right, number 1 was a circle, number 2 was an ellipse, number 3 was a parabola. Guess what number 4 is going to be? Can you guess? Sure, yes, this is going to be a hyperbola. So if you want to guess, that's good. And to be a hyperbola, what must be true? Neither A and C have different signs, but neither A nor C equals 0, right? I will assume if you just say A and C have different signs, I will assume that you mean neither one of them is equal to 0. All right, but let's do the math here, because on the test you're only going to have one or two, you're not going to be able to do this by process of elimination. So for each point, random point, I don't know the x or the y coordinate, that point's distance from a fixed point whose x and y I know is twice a distance from a line. So I have the point 40, and I have the line x equals negative 4, and I have a random point P. So the first distance is easy, right? That's distance 1. So distance 1 is twice distance 2. So let's do the easy one first, right? The distance, what is the distance between an unknown x and a known x of 4, an unknown y, and a y coordinate of 0. That's the easy one. Now, how about the distance to the line? I kind of regret now not making any of these lines horizontal, right? You would do the exact same thing if I said the line y equals negative 4, right? It's just instead of drawing a horizontal line, you would be drawing what? A distance line, I mean. So what is this distance? Right? And if you're not sure, again, you think about this one. So what is this point on the vertical line? Well, x is always negative 4, and y, the y coordinate isn't known, but it's the same as this y because you just went across, right? You did not change your height. The change in y was 0. 0. But what is the change in x? The unknown x minus negative 4. All right, let's do our algebra. Square both sides. As long as this whole side is under the radical and the square undo one another. And that's just y squared, right? Y minus 0 squared. Don't forget to square the 2, right? This is actually 2 squared and the radical squared. Oops, I kind of went through that. Right, and just 0 squared. Don't forget order of operations. You got to square first. So I'm going to collect everybody on one side because I need to be equal to 0. But I notice that I only have 1x squared over here and 4x squared. So I think up in my workspace, I'm going to go to the right side. So I'm going to say x squared, subtract x squared from 4x squared, and I get 3x squareds. I need to take this y squared over to the right side, and there's no y squareds to combine it with. Then I'm going to add 8x to this 32x. And then I'm going to subtract 16 from this 64. So what do I have here? Looking at the coefficients of the squared terms, which have the most impact on the shape, A is 3 and C is -1. A and C have different signs, therefore I'm a hyperbola. Okay? So your homework tonight, right, goes through, right, each one of these. You should have at least one of each kind, right, because you have 3, 7, 9, and 11. So once again, you'll be able to guess. You have one of each kind. Number 13, watch out for number 13 is kind of a weird problem, right? It's kind of a thinking problem more than an algebra problem. Okay, the other ones, 3, 7, 9, and 11 are very straightforward. Use this handout as a guide to remember what to do, and the notes in your notebook. But then number 13 is kind of like out there, right? It's a little bit of a stretch. Okay, tell me what you think about it. All right, remember this homework. I'll check this on Wednesday. Do Wednesday. Now we have short periods, Wednesday and Thursday. They're only 20-some minutes long. I only have one lesson, but what I'm going to do is make another video for the last objective, right? This locus of points was the second to last objective. The last objective that we have to cover before the test, so it's going to be a full week before the test. The last objective is systems of conics. And I want you to remember linear systems and all the math we did to solve linear systems. Now we're going to solve systems that are just not linear. But what I'm going to do is make a video for this lesson that you can watch in class Wednesday. But you won't be able to finish it in Wednesday, but you can watch in class Wednesday and Thursday. But I think better than that is if at some point, start on Wednesday maybe, but finish the video Wednesday night, and then homework problems, try homework, and then Thursday in class maybe you can just ask me questions or ask peers questions about the homework on Wednesday. I'm sorry, on Thursday. Friday will be some review, but we'll also have an IB problem. IB number 5 will be with partners. IB number 5, and then that will be 15-20 minutes, and then we'll do some review, and you'll get another, we'll have a poster assignment that I'll give you on Friday. Okay, so this is all upcoming. Okay, and the poster assignment will be an individual poster that is due the following, that's Memorial Day weekend, so due on Tuesday. The poster assignment will go in the IB category to kind of, Again, notice that I put lots of things in that IB category even though it's a 15% category. There are things in there like the trig little book, the poster activity in class, you know, little things like that I put in the IB category because the IB problems themselves are kind of hard, right? So that's what's upcoming. We will have, I'll get you one more IB problem too. We'll have IB6 sometime, probably before the test as well, so that we can have a decent number of points in there for you. All right. So have a good rest of your day, and I will see you on Wednesday.